Yeah, greetings all, and today we have one of the past book questions and physics, and this is 20 16 private candidates. And this question is about three quantities, the relationship between mass, volume, and as well as density. You see, so the question reads: a small metal ball of mass 100 grams is gently dropped. You see, it's gently dropped into a measuring cylinder containing some water. You see, the water level rises as illustrated by the diagram below. So we are given the diagram and we are required to calculate the density of the material of the ball. So in this case, we are given the question reads a small metal ball of mass. So we are given the mass of the ball, which is 100 grams. You see, we are given the mass of the ball, 100 grams. And what we are required to calculate is we are required to calculate the density of this ball. You see, we are required to calculate the density of the ball. So since we are given the mass of the ball to be 100 grams, and we are required to calculate the density of the ball, but we are not given the volume of the ball. So I think we have to figure out the volume of the ball, because the relationship between the quantities, mass, volume, and density, wherein we have density to be equals to mass all over volume. So since we are required to calculate the density, so the density that is going to be the mass of the object or the substance or the particle divided by the volume of that same particle. You see, so in this case, we are given the mass of the particle in terms of grams, and we are not given the volume directly, but we are given two diagrams here. You see, we have this cylinder one and cylinder two, but initially, the original cylinder, the volume of this cylinder is 40 centimeters cube, just like you have a cup, and with some amount of water inside that cup. Let's say the volume of that water inside that cup is 20 centimeters cube. If you drop an object inside there and the volume of that cup increases to, let's say, from 20, it increases to 25. So what's going to be the volume of the object or the particle you immerse or you place or you put inside that cup? So since the initial volume of the water in the cup was 20 centimeters cube, so when it drops something there, it increases to 25. What's the volume of the object to drop? So just subtract the 25 minus 20 is going to give you 5. So that 5 is simply the volume of the object that you dropped. So similarly, the volume of this initial of this container of this cylinder is 40 centimeters cube. When this ball is being dropped here, as in the case of the second diagram, the volume increases from 40 to 48. You see the case. So here we are tasked to find the density, but we cannot find the density wherein when we don't know the when we don't know the volume of the material, and the material here is the ball. So since the initial volume of this object, of this material, or this cylinder was 40 centimeters cube, when an object or a ball is being dropped inside and it increases to 48, so what's going to be the volume of the ball? So we subtract the volume of this original one, which is 48, minus the volume of the initial one, which is 40. That will give you the volume of this material. So just after we have the volume of the material, we can easily move on to find its density. This is a straightforward question. Now, we say mass of the ball. Say mass of the ball. Let's drop it here. Mass of the ball. Mass of the ball. So it is given as 100 grams. And we need to find the mass of the we have to find again the volume of the ball. But the volume, initial volume of the cylinder, let's say V1 was 40 centimeters cube, and we have the final volume of the cylinder. Final volume of cylinder, we call it to be V2, which increases to 48 centimeters cube. You see? So in this case, we need to find the difference in volume. So difference in volume, or we can say the volume of the ball. Okay, so the volume of the ball here is going to be the final volume, which is V2, minus the initial volume, which is V1. You see? So volume of the ball now is going to be V2, which is final minus V1. But what is V2? V2 is 48, because the volume from this initial point, from this bottom point to this top point is 48, which is 48 centimeters cube, minus the volume of the initial from here to here, which is given as 40 centimeters cube. So we subtract 48 minus 40, this will give us 8 centimeters cube. So we have the volume of the ball. This is the volume of the ball, volume of the ball. So since we have the volume of the ball, but we are required to calculate the density of the ball, but we have density to be mass. The unit now for this case is in grams, mass in grams, divided by the volume. The volume in this case is in centimeters cube, centimeters cube. There is it. So since we are required to calculate the density, so what is the mass? The mass is given as 100 grams divided by what is the volume, which we have calculated as 8 centimeters cube. So the density of this object will be 100 grams divided by 8 centimeters cube. So this will give us 12.5 grams per centimeter cube. So this is the density of the ball we are required to calculate. So I think this is just a simple and straightforward question. It's just a simple and straightforward question. You see? So the question is very simple. So when you come across these questions, you just have to try to carefully determine or try to carefully identify the quantities given. So for this case, three quantities: the density, the mass, and as well as the volume. We are required to figure out the density of the material or the ball. You see, we are in directly, the mass of the ball is given, but indirectly, the volume of the ball is not given. So the two diagrams are given to us. So we have to go through the diagram to figure out. You see, if you have an object and it has a volume of 2 centimeters cube. If you place something inside that object again, it increases to 5. What is the volume of the object you place inside there? Just try to subtract the difference. So the difference you are going to have, 5 minus 2, is going to give you the volume of the material you insert or you place inside that object. This is it. So this is just a short problem. Thank you. Stay blessed.